Okay, can everyone see? Thank you, Anita, for the introduction. And my name is Joshua Essery. I'm a recent graduate of the Curriculum and Pedagogy Department, University of British Columbia. I've been working on a way to integrate language and culture and legend and dance into mathematics. And this is some of what I've come up with. The information prepared in this presentation is solely owned by the Numgese First Nation, the Kwakwaka'wakw language group. There's a lot of cultural information, and that information is retained by the knowledge keepers. I have permission to share this to you for educational purposes, but the ownership remains with them. I'm also transmitting from Sinemo of the Homokium language group for today's presentation. A little about me, very quickly. This is us getting ready for a cultural celebration. Some of my colleagues, Raven Baruden, Gloria Alfred, and Jenna Peterson on our right is our principal of the school. The positionality for the creation of this, some of the inspiration. I'm trying to change the pedagogy of teaching, especially teaching math, changing from the content of competency-based curriculum and into a cultural responsive teaching mode. As all great lessons start, it started very holistically. We were preparing for our winter celebration, and we were trying to figure out how to actually act out some of the legends. My students chose the legend Zunaqua. She also goes by the name of Sasquatch, Bigfoot. So a character very much of a supernatural origin, but in Kwakwaka'wakw tradition, she hovers around the edges of the forest and steals children. This is her function, and she'll take them back to the cave and eat them. So very much of a warning, sir, very much of a moral to this. And the question was asked while we were trying to figure out how to act this out. How big is Zunaqua? How big is this person? And that question stuck with me. It's like, could we possibly? Is there enough data that we could access to actually approach answering this question mathematically? So embedded in this slideshow is a version of the dance. For time, I won't be showing it, but it is available through the Umisi Museum. There's also a guided tour of all of many of their masks. But this is a picture of Zunaqua. This is how she is presented in Kwakwaka'wakw tradition. So she has these big lips and these big hands. And to approach the lesson, we make a series of mathematical assumptions. So we approach how big she is by the basket that she wears in order to kidnap these children. So the first stop is to attend the place where she would appear from the spirit world. So they go to the Ashley, the forest, to see the size of the trees, the topography, which determines how the basket must be worn. Then we visit the dance, and the dance, we see her scooping the children up like this with both hands. So the basket is worn on the back. It can't be above the shoulders, and the topography suggests it can't be below the knees. So this allows us to make certain assumptions. Also, part of the legend suggests that she took 20 kids at once in this one version of the story. So we can begin to suggest how big the basket must be, based also on the size of the basket and the shape of the traditional basket making. So we visit the Umisi Museum to see how this would have been done. So all of this, we can start approaching this in a mathematical perspective. I began to lay out what this could look like in a unit. And the first time you kind of do anything with your students, it can go really well, or it can fall flat on its face. And I think it was a little bit of both with this one because they already know the story very well, but I'm introducing a mathematical component to it, which made it exciting for them because they were already deeply invested, and we got to go outside and do math, which is always a fantastic time. But in order to sort of organize it in a way that we could approach it in a very reasonable way, I was looking for something that I could kind of house it in. So through the research and through the work that I've been doing through the master's degree program, I've been using Cynthia Nichols' framework that was created in the Haida Gwaii to kind of approach and make sure that not only are we responsibly hitting all of the components that one would expect to see in an Indigenous lesson, but also laid out in an intentional way. So you don't do sort of something accidentally and it's, oh, I wish I did that instead. It gives some grounding to it. It gives something you can hang your hat on as well. So the pairs framework that I've been using is laid out in a way that you can make sure that all of these Indigenous components are being hit during the creation of the lesson. And as it's being rolled out, you can also make sure the students are deeply involved in that component. It's not something that is like, oh, we're going to go do this again. It has a new purpose. You need to examine it through a new lens. You bring them to what they already know and then guide them to something new. So the sense of place, we visit where she is supposed to appear. Um, the topography, the shape of the forest speaks to that, and we can see it now mathematically. We take action trying to understand how big she must have been. The inquiry, they're all working in smaller groups. So they're working with each other to try and figure out, they're collecting these data, working with the numbers. We actually go and measure how big the kindergarten students are to gain information that can speak to how much volume this basket must have held. The relationships, they're built because they're really excited to do this. They're working with each other. They're working with the little kids. They're introducing them to math and measurement and things of this nature. And then the story work component, it brings them through their legends in a way that they haven't. It's almost like a choose your own adventure, and it's really been a lot of fun to do. I created the unit plan to try and lay it out and give some intentionality. This is just an overview of that unit plan. So it begins with an approximate time frame, so you have an idea of flow and the general information that you want to guide the students to. You want them to discover it on their own for the basis of inquiry, but you also want to steer them into the direction just in case they get too far off the path. So you can have guided discussions, and through the basket, the dance, and the visit to the Ashley, the forest. Discuss how the baskets are worn, where it's worn, the construction of the basket. All of that can be done at the museum. And the shape of the basket is asserted by the museum exhibits. From that, they start collecting data, so we can bring this into a mathematical perspective. And they get to measure how they want, whether it's in centimeters or inches. Both are useful discussions. The manipulation of those data, it also gives you something that they have handed in, they've created. So for an assessment purpose, you have something now that shows that they understand the mathematics involved. And not only that, it gives you a chance to rehearse the precursors that would be required to do this. So the addition, subtraction, all of the arithmetic that they would need in order to approach this can be hit. They're also hitting these lessons on volume when they need to know it in order to carry on with the journey. That allows the information to stick because it's a lot more relevant to them now because they have now seen themselves and their culture in the mathematics. So finally, the last set of time frame on the right there is discussion of possible ways or shapes of the basket to determine its volume. And then once we have that, we can determine body shape dependent on ratio. So the assumption is that Zunaqua is more or less human-esque. So the ratios of shin and of neck and of head, we can base those ratios on a person once we have the idea of how big her torso is. It's actually quite fun because the conclusion is that she must have been this tall to do this, and that's based on the data that the students collect. But it's also the case that Zunaqua is a shapeshifter. So she can be as big or as small as she wants, but she must have been at least this big in order to accomplish the task that we have discussed. How am I doing for time?
Yeah, I think your time is all done.
Okay.
Yeah, so
Um,
can wrap up fast if you can do.
say again.
Yeah, you can wrap up fast because already you took more than 12 minutes.
Oh my goodness. Okay. So my next steps, right quick, are to expand access to the legends, to try and build a whole narrative through the creation stories of the Kwakwaka'wakw, to see if I can hit all the components of BC Math's curriculum through this. So they follow a character, and it's a journey. We go through all of it. So that's where I am right now in this. So thank you very much for attending. I can entertain any questions that may have arisen.
So thank you so much, Josh, for your presentation. And we have 2-3 minutes for questions. We can take some questions. You can type your questions if you any one of you ask and want to ask in the chat box.
Josh, how did the students make the estimates for the size? You had that one slide that asked how big the basket is, how many children would be in the basket, etc. Can you say a little bit about how the students were able to make those estimates? What
Sure.
strategy they used?
The estimate for the 20 children that came directly from one version of the legend. So one version of the legend that we listened to gave the number 20. So that was a solid number that we could work with that was based on the original data. Um, where they collect the data, we have measuring strips that we use, and we take them up to the kindergarten students, and we measure, say, 3 of them, the ones that would stand still long enough for us to do this. So we would measure from across the shoulder, and then their height from head to toe, and then their approximate width. So at their widest point, how wide they are, and then we would do the same thing with them in the crouch position, based on the idea that they're not all going to be upright in the basket. Some are going to be, So we get 3 pieces of data for them to be length, width, and height at the standing, and then 3 pieces of data length, width, and height them crouching. And that gives us enough data to work out an average, and then we can multiply that average to 20. They create their own data gathering charts based on a template or a suggested way of doing it. But I want them to be creating all of this as much as they possibly can. And I collect those data, and we talk about better ways of doing it, or if they've come up with a new way of to collect those data, that's even better. I have laminated ones that we take out to the forest. That way we can use the wax pencils when they get wet, because, well, we get lots of rain. But yeah.
Yeah, we have one question in the chat.
Okay.
Heather Woodman is asking, what was the timeline for this unit?
This unit is approximately 12 to 14 lessons. So better part of 3 weeks, because we all know how incomplete school weeks are. So yeah, I would give it, a solid 3 weeks, maybe a month. And that would be based on, say, 45 minutes to an hour class each day. So yeah, it's fairly in depth.
Thank you so much, Josh, for your inspiring presentation.